Hello everyone. So as I'm sure many of you are already aware, starting from 2025, paper 2 from 0580 will become a non-calculator exam. And for some of you this might seem like a challenge, and this is why I'm creating this video in order to guide you through everything you need to know to master this paper, including key topics which have been impacted the most by this change, tips and strategies to succeed. So the key topics that have been impacted by this non-calculator change. Firstly, the most important one is number skills. This involves things like fractions, decimals, and percentages, rounding and estimation, and of course, basic operators and, in essence, mental math. So, if we go through this example of fractions, decimal, percentages, this is a similar question that you might encounter in the exams. Calculate 25% of 160. 25% of, so to do this question, you have to convert from this percentage to a fraction. Or you could do a decimal, but it would be easier to do a fraction. And you should know that 25% is equal to 25 over 100, which is equal to 1 over 4. So for this example, it's 1 over 4 multiplied by 160. And this is an example of mental math skills that you'll need to have to do well in your exams. And here, if you do 25% of 160, is therefore equal to 40. Another area that they might ask questions on in the exam is rounding and estimation. For example, rounding this number to 2 decimal places, that's fairly easy. 237.86. And estimating. So this is a question, a type of question that I think will come up in the exam. It's looking pretty probable right now, because all we have to do is round both numbers to one significant figure. So this rounds to 20 and this rounds to 3. And therefore the estimated value is 60. Okay, so now another important one here, trigonometry. And by trigonometry, I'm talking about exact values. So you'll need to know these exact values off by heart for sine, cosine, tangent of each of these, of 0, 30, 45, 60, and 90. And to begin with, to memorize off by heart, you need to know that sine of 0 is 0, cosine of 0 is 1, and tan of 0 is 0. For these other values, you could memorize them, but I think the easier way is to derive the results by drawing triangles. So if we draw an equilateral triangle, of side length 2, and we split it in half like that. So now this has a side length of 1. Now remember, this is equilateral, so this angle is 60, this is 90, and this is 30. So now, if we cast our mind back to SOHCAHTOA, which by the way is in my full formula booklet. So if you want to check, if you haven't already checked that out, it's on my main YouTube page. You can find it there. It's a full free formula booklet. So sine x is equal to opposite over hypotenuse. Cosine x is equal to adjacent over hypotenuse. And tan x is equal to opposite over adjacent. So if we look at this triangle, sine of, we're focusing on 30. So sine of 30 is equal to the opposite over the hypotenuse, which is 1 over 2 in this case. So therefore sine of 30 is a half, 1 over 2. And now cosine of 30 is adjacent, which is this side, over the hypotenuse. And we can calculate the adjacent side using Pythagoras' theorem, which states that if this side is a squared plus 1 squared is equal to 2 squared. Hence, a squared is equal to 3. And therefore, a is equal to positive root of 3 since it's a side length. So we can write that here. A is the positive root 3. Therefore, cosine of 30 is equal to adjacent root 3 over 2. So fill that in here, root 3 over 2. Now for tan 30, there are two ways to do this. Now, we go either opposite or adjacent. So the opposite side of 30 is 1, and the adjacent is 3. So that would be 1 over root 3. And, or, another way you could do this is to know this identity, tan x is equal to sine x over cosine x. I think that knowing this identity will really help in your exams, because you only need to remember the values for sine and cosine, and then you can calculate the value for tan. So for 30 degrees, tan x is equal to 1/2, which is sine x, divided by cosine x, root 3 over 2. And then the 2's cancel, and you're left with 1 over root 3, as we've seen before. So we can do the same thing for the 60-degree angle. Sine of 60 is equal to opposite over hypotenuse, so root 3 over 2. And for cosine, it's adjacent, so 1. The adjacent side divided by hypotenuse, so 1 over 2. So a half. Oh, sorry, this is for 60 degrees, not 45. And then if you do the same, use the same identity, tan x is equal to sine x divided by cosine x. If you divide this by this, root 3 over 2 divided by a half is just root 3. So now to find the remaining, to fill in the remainder of this table, we can draw another triangle. This time it's a 45, 45, 90 triangle. So we have an isosceles triangle with the base angles at 45 degrees and side length 1. So sine of 45 is equal to the opposite side. So we can use any of these 45-degree angles. Let's just say we're using this one. Equal to the opposite over the hypotenuse. But we don't know the hypotenuse, so we can calculate that using Pythagoras' theorem. A squared plus b squared equals c squared, where c is the hypotenuse. So 1 plus 1 is equal to c squared. And c squared is equal to 2, hence c is equal to root 2. So this is root 2 over here. So therefore, sine of 45 is equal to 1 opposite divided by hypotenuse. So 1 over root 2. Sine of 45, 1 over. And for cosine, it's the adjacent side divided by the hypotenuse. And so if we use this again, the adjacent side is 1 again, and the hypotenuse is root 2. So it's the same for cosine, 1 over root 2. And now since both values are same, if you use this identity again, tan x is equal to sine x, both values are the same, and hence when you divide them, you get 1. Now for sine of 90. So now if we take in perspective of this angle, this 90-degree angle, the opposite side we see is actually becomes the hypotenuse. So the opposite over hypotenuse is the same as the hypotenuse divided by hypotenuse. They both have a length of root 2. So therefore, sine 90 is just 1. And now for cosine 90, we can't use the same logic. We can't use a 90-degree angle because there are two sides which are adjacent to it, which doesn't make sense to use cosine. So you'll have to just remember that sine x is 90, cosine x is 0. And now tan x is sine x divided by cosine x. So 1 divided by 0. But remember, you can't divide by 0. So for tan x, we get an undefined value. This is undefined. And yeah, that's the trigonometry values that you'll need to know for the exam. Another way you could, if it helps, you could, to visualize it, if I draw the graphs of each of them. So sine x. Sine x looks something like this. It crosses here at 0, 0. Hence we see that when x is 0, sine of x is 0 as well. And this right here is 91. So when x is 90, again we see that the result is 1. And this will just help you like visualize a few of these. If you do the same thing for cosine. Cosine x starts from up here. It's like that. So it starts from 0, 1. So when x is 0, cosine x is 1, as you can see from the table. And this right here is 90, 0. So cosine of 90 is 0. And finally for tan, it looks a little different. Looks something like this. And these dashed lines are called the asymptote. It's where this curve continues to approach. As you can see, this curve continues to approach this line, but it will never actually touch it. And this is the reason why tan of 90 is undefined. Because this asymptote line is actually where x is equal to 90. This tan graph never actually touches the asymptote, hence it's undefined. Again, this is 0, 0. And that's just a little visual interpretation of these values. And now we move on to the next one. Number 3, surds. So surds are an irrational root. So for example, root 5 or root 2, these are surds. So you need to know one key property of surds is that one surd, root of a, for example, multiplied by another, root b, is equal to the root of their product, ab. And this will help you a lot, especially when one of these numbers is a square number. And then you can just take the square root of it as an integer. For example, when we're simplifying surds, and we have this, we're asked to simplify root 75 minus root 3. The way we do this is we find the square numbers, which are factors of 75. So 75 we know is equal to 25 multiplied by 3. And 25 is a square number. So if we rewrite it as root of 25 multiplied by root of 3, this is root 75, remember? Minus root 3. We can now do this. But we know that root 25 is just 5. So this becomes into something much nicer. 5 root 3 minus 3. And then this is therefore just equal to 4 root 3. This is because if you let x equal to root 3, this becomes 5x minus x, which is just 4x. And then after you substitute in root 3 back for x, you get 4 root 3. So the answer for this is just 4 root 3. And that's as simplified as it goes, since you can't simplify root of 3 any further. And now we move on to rationalizing the denominator. This is the denominator. When we want to rationalize it, we want to remove the third term from it. So if we start with a simple example, for example, 6 divided by root 3. If you want to rationalize this, you want to remove the third. So what you do is you want to multiply both sides by the same third. Remember, multiplying by this is just multiplying by 1, so it doesn't make a difference to the fraction. We're not changing the value. And after you do this, you get 6 root 3 on the top, divided by root 3 multiplied by root 3 is just root 3 all squared, which is just 3. And then this can further be simplified into 2 root 3, because 3 divides 6 twice. 3 goes into 6 2 times. So 2 root 3. But now when we have some more complex examples like this, when we have a integer term, to rationalize this, you always multiply by the conjugate pair. The conjugate pair is the exact same expression, but with the signs flipped. So instead of 1 minus root 5, we multiply by 1 plus root 5. The reason we do this is because if we have so in this case, we have 1 minus root 5 in the denominator multiplied by 1 plus root 5. And this can be rewritten in the form a minus b, a plus b. And if you remember, this is the difference of two squares, a squared minus b squared. If you expand this out, you'll see that it's equal to a squared minus b squared, which is very convenient for us, because now in the denominator, this is just 1 squared minus root 5 squared. And so that's just 1 minus 5, which is negative 4. So in the denominator, we have negative 4. And in the numerator, it's just 8 plus 8 root 5. But remember, you can factorize the numerator as this all over negative 4. And so the negative 4s cancel out. And ultimately what you're left with is negative 2 minus 2 root 5. And that is the answer for that question. Okay, so now another topic is algebraic manipulation. So this should not be too difficult. It just involves things like simplifying expressions, which involves expanding brackets. So in this case, 2x squared plus 6x minus 4x. And the way we do this is we multiply each term out by the bracket. So 2x squared plus 6x minus 4x is equal to 2x squared plus 2x. And another relatively easier topic, just solving equations. So if you move all the x's over to one side and the constant terms to another, get 5x is equal to 20. And dividing 5 by both sides, x is equal to 4. Finally, substitution. So in the exam, they might give you this equation, an equation of this form. For example, y is equal to 3x squared plus 5. And we're asked to find y when x is equal to 2. So all we do is we substitute the given value of x into the original equation. And if you just, here's another important part where mental maths really helps you, is in doing small calculations like these. So if you just write out your full steps, y is equal to 17 when x is equal to 2. And that's that section done. Finally, we move on to geometry and some basic mensuration. A very important one here is Pythagoras' theorem. If you remember, earlier we used the Pythagorean theorem in these triangles to calculate these values. And if we go back to this table, actually, we can see we can actually rationalize these values from like so. That's why I left a little gap here, so I can come in later and rationalize it. It just makes it a lot nicer to deal with, especially in calculations. But anyway, if we go back to the topic of geometry and basic mensuration, you need to be familiar with Pythagorean triples. For example, 3, 4, 5, 6, 8, 10. These are all Pythagorean triples, which means you can construct a right angle triangle from these values. And some triples might not be, you might not be as familiar with some triples, like this one, in which case it's just best to work with the formula. So c squared is equal to 9 squared plus 12 squared, and this is equal to 81 plus 144. As you can see here, it would be extremely handy for you to know your square numbers. Ideally, you should know your square numbers up to 15 and your cube numbers up to 10. You should also know the first few prime numbers and square numbers. That would really help you. So if we go back here, we see that c squared is equal to 225. And if you are familiar with your square numbers all the way up to 15, you'll know that this is equal to 15 squared. And therefore c is equal to 15. So in this case, c is actually just 15. Finally, they may ask you the area of 2D shapes. I won't go into too much detail here, but if you are interested, do check out my formula booklet. It has all the formulae for every single shape that you need to know, and the area formulae and volume. But I just want to point out here that in the area of 2D shapes, they may, for example, give you a semicircle, let's say, and they give you that let's say the diameter is 10 centimeters, and they ask you to calculate the area of this semicircle and to give it in exact form. What exact form is a term that you'll need to be familiar with for your exams. Basically, what it means is to leave any surds in your answers, or to leave any pi values, because obviously you can't simplify that without a calculator. So if you want to calculate the area of this semicircle in exact form, leaving your answer in exact form, firstly, the radius is the 5 centimeters, is the diameter divided by 2. And the area of a semicircle is equal to pi r squared all over 2. So now if we just substitute this in, we see that our answer is 25 pi by 2. And we just leave it in this form because it's exact form. We have left our pi. We can't simplify it any further with our calculator. And so, yeah, I mean, that's all the major topics that have been impacted by this change to the syllabus. And a few tips I would give for the non-calculator paper is to firstly practice mental math daily. I can't understate this, but I can't overstate it, but it's really important to know all your basic operators like addition, division, subtraction, long division, knowing your square numbers, triangular numbers, prime numbers, cube numbers, and simple operations. Again, very important. Another tip I would give is to write out all the steps. As you can see here, I've written out all the steps for every question I did. I haven't skipped any steps. This will ensure that in the exam, first of all, you'll get partial marks for writing or working out. And secondly, it'll make it easier for you to identify any errors that you make while working. Because, of course, without a calculator, it's quite easy to make careless errors. And by showing your steps, it means that there's a lower chance of making these careless errors as you normally could without a calculator. And of course, once you get an answer, if your answer doesn't seem reasonable, for example, if in this one 25% of 160, if you got something like 85, you should go back, look at it, and use estimation to check answers. Because you know that 50% of 160 is 80. And if you're getting 25% of 160 as 85, that clearly doesn't make sense because it's larger than 50%. And so then in the exam, go back and review all the steps that you've done. And you should also practice these specimen papers that Cambridge has released on their website, the non-calculator batch, and do them in exam conditions, timed conditions. You could also go back to all paper 2s before and try to do them. Try to do the parts that you can without a calculator. And you'll realize that most of the parts in the paper don't actually need a calculator. Of course, just some of them will need a calculator. But other than that, you should be able to do the majority of previous paper 2s without a calculator. Finally, memorize key formulas and values, such as this trigonometry table. And the area, volume. It's very important that you are familiar with these formulas and their applications. And if you need some guidance in remembering all of these formulae, use my full IGCSE Maths formula booklet. It's for free on my YouTube page. And it goes through essentially all the formula that you need to know to master your IGCSE exams in 2025. And that's it. If you found this video helpful, leave a comment with your questions or topic suggestions, and don't forget to subscribe for more IGCSE content. Thank you.